In this video, I will show you how to use MinMaxSearch program. Right after you open the window, this is how the program appears. In general case, we will have X access in the same file as the data, so you have to uncheck this check mark. You have to click on Browse, and you have to choose your file. In my case, my file will be this single file from the example out. How to obtain this file, how this file is generated, is explained in the TxtShuffle or Nematicity program, depending on is this one channel or two channel measurements. I click Browse and I go to my folder, example out, I choose file, I open it. Once file is loaded, I get the information of the first point, the last point, and the fluence. In this case, it's fluence, it can be temperature, it can be power. Then I can look through all of the scans, I can go directly to the last one. And right now, from this type of data, in this program, I will be interested in this minimum. In some other cases, I may have another maximum here, or I will have here not minimum but maximum. In this case, I need to identify all of the search parameters for this minimum. So firstly, I know it's minimum, I choose minimum, and I know approximate range of this minimum. It's something from 10,000 to 20,000, and it does not shift too much. So I can put here 10,000 to 20,000. Notice when I put 20,000, right now my window will be scaled only up to 20,000. So then I need to put points near and step size. What are these two variables? These two variables correspond to the first cycle, when I will go through every point with a step size of 50, for example. So 50, point number 50, point number 100, 150, etc., starting from the first point of fit region. So in this case, it will be 10,000, 1,050, etc., until 20,000. Points near is how much point I will account for, because if you look closely, the data has some noise. So in my case, I don't want to look at minimum or maximum directly in one value, but I want to have some delocalization. I want to know the trend of the values, not just it's because here it can be lower, bigger, lower, bigger. I need to know the global dynamics. For this thing, I use step size and point size. Step size can be less. At this point, it depends on your step size on experiment. Another thing that you have to set is the Savitsky-Golay filter. What is that? Additionally, to reduce my noise, I can use a filter option. For example, I will put 77 points, and when I click next, you see that the new line appears. And if you look closely, you see that this green line, it also averages some of this high frequency noise. So when looking for minimum position, I will not be reacting to noise, but I will be reacting to trends of the data. On the top of that, there are additional option is to use parabolic fit or p-fit, that is I will use. What it does that after the first cycle, after I go through my region and I found the lowest points, instead of just giving the lowest point as a result of my minimum search, the program will try to fit the functions, my data around it, using parabola. Then it will define the minimum point, not from the point that it found, but from the minimum of parabola. Because, for example, in some cases, for example, like this, my minimum point is somewhere here, but if I try to fit parabola around it, my minimum will be shifted more likely here. more to the center. The size of parabola you choose on your eye. Usually I go for visually. For example, in this case, I see that my minimum at least needs this size. So if this is 12,000 and this is 18,000, so probably 6,000 points should be enough. After I do everything, I click set again. All of my parameters are set. The next step is to actually click search for all. And when all scans done, right now I can change the file name. The file name, it will automatically add minimum per feed and .txt. So I will use just that. It's, for example, channel 2, and I click save. And you will see that here a new file will appear after it's saved. So new file appear, as you can see, minimum per feed was added. We can check this new file. So I click on import and then I go to the folder where I have my prepared tests. So here is the file that was created, and then I click open. And as you can see, the output of the program is three columns files. First one is fluence. In this case, it can be temperature, it can be power. Second one is the position of minimum, which is what is the time delay corresponds to the minimum. And third one is the value, is how much transient reflectivity or signal intensity in this point. So you can, if you want, you can plot, and then it's already up to you what to do with this data.